So today I'm going to show you how to design a basic circuit diagram using EasyEDA. EasyEDA is an online tool, a website-based tool that you can use to design your circuit diagrams and also do the PCB design. And you can order quickly through their website. There's a link on the website for ordering the parts from JL PCB. All right, so I'm gonna show you all that quickly. So this is what we've designed already. So if you want to order the PCB, you can go to the let's go here. Yeah, so you can go to the this generated GABA file. So file fabrication, and then you can do the checks, and then you can just order quickly from JLC PCB. Right, we're gonna go through the design. We just finished this one, and let me show you how it looks. The 3D view, how it looks. So I think I like what I'm seeing here. This is an 27 megahertz receiver front end, and I can change the colors. Let me just go quickly to the board color. I can make it red. I prefer red, so you can just use the click, drag around, and see how it looks. Right, and if you want to move the board itself, you can use the right click to move it around. And then if you want to use green, I see some people like green, so you can use green as well, right? You can write text. I'll show you how to write text on it, how to put the holes for your screws, and how to do the routing. All right, so let's go quickly and start a new project. So I'm just gonna go on file and then new. I'm gonna do schematic file first. File, new, schematic. The first thing is you have to have the circuit diagram you want to clone or you want to design, so you can draw it by hand. But I found this one online and I thought we can just use this to start, right? So now the component you need here is this transistor, a bunch of resistors and capacitors, and then a crystal. Then I think the rest will be coils. So there are about 4 different components: crystal, resistors, capacitors, transistor, and then finally let's go crystal, resistors, capacitors, one transistor, inductors, yeah, and then the power supply. So 5 components we'll be putting down here. So let's go to our EasyEDA website. So we're gonna go to the common components, or we just go to library. Let's go to the library and pick the transistor. We need the BC 547, so we're gonna pick one of them. We just need one, so we're gonna close this. And oh, okay, I think we didn't pick that, so let's go back again. Library, I'm gonna get this one. This is what I prefer. You can also see the look here, and that's what we're going for. So we've picked it by just clicking on it. So I'm gonna place it on the board. So when you scroll down with 2 fingers, it will zoom in, and then when you scroll up, you zoom out. So let's zoom in a little bit. That's what we need. And then we need a bunch of capacitors. We're gonna make them surface mount. So let's take the common libraries, which is this here. I'm gonna go for capacitors, and then I'm gonna get okay, we're gonna add something they didn't have there. So let's get an LED. We get an LED, just one LED. We place it here. And then we're gonna go back and get some resistors. Okay, resistors, we're going to make it surface mount. So let's take um let's do 0805. I think it's going to be a little bit big. Okay, let's do 0402. Sorry, 0402, and then we're going to pick that again. So place the resistors here. One, no, this is an inductor. This is an inductor. We need a couple of inductors, but I don't think this is what I want first. Let's go for the resistors first. We need the resistor. Okay, it's a little bit up here. So we're gonna do surface mount 0402. Is it too small? Let's do 0603. Let's use this one here. All right, we're gonna get a bunch of them. One, two, three. How many do we have? One, two, three. So we have three. And then we're gonna get inductors, two inductors, and then this kind of transformer inductor. So let's get two inductors. One, two inductors. Go back here. I'm gonna go to inductors. We can also do surface mount inductors. It's already 0603. So let's resistor. An inductor is down here. It's already 0603, but it's the axial type. So let's get the surface mount type. So we're gonna get inductors. We have two of them. One, two. And then we're gonna go back and check what else we need. We need capacitors. There'll be one, two, three, four, five capacitors. We're gonna make them all surface mount. One, two, three, four, five. All right, so let's go back and get five capacitors. Surface mount. We're gonna do um, let's see. This is a capacitor here. Yeah, let's do five of them. That's an inductor. I want to pick a capacitor. Yeah, we're gonna do five of them. One, two, three, four, five. All right, five capacitors, and we need a crystal. Do I have a crystal on this side? Crystal, crystal. I don't see it here. Maybe I'm going too fast. Okay, so we're gonna go to the library and pick it there. So we're gonna do 27 megahertz crystal. They just hit enter to search for it. If it's in the component library, you will see it there. Um, okay, so we don't want this type of crystal. We need the two terminal type, not the four terminal. Um, yeah, this is the type we're looking for. So we're gonna take this one here. I'm just gonna place it on the. So to reorient this, I just have to hit enter, space key, sorry, to reorient it. And then I just click to place it. I think that's the major thing we need. We're gonna need one extra resistor, so I'm gonna duplicate one of them. So Control C, Control V, so I can place it there. Now I'm gonna just zoom out a little bit so I can see all my components, and I'll start my placement. So my resistor first, I'm gonna use that to indicate that power is in this circuit. So with the space, I'm arranging the orientation of the LED, and then I'm gonna place the components around the transistor because that's my key my main, actually my only active component. So around the transistor, I have a resistor and a capacitor. So let me start so that the numbers will go from left to right. We increase from left to right. So I'm going to have two resistors. So one and two is going to be the base of the transistor, one and two, and then the crystal. So let's do that, one and two, and then the crystal. So let's go here and do one and two, add one. And we're going to click the actual resistor, R1, and then R2. Right, and then I'm going to have the crystal at the input side, which is here. So I'm going to relocate this labels just by dragging it to wherever I want it. And then, alright, these two are connected already. We don't need to connect them yet. We'll figure out how they are connected later. So one and two, let's place it here so it's easy for us to connect and not have all the wires running into each other. So, alright. Then the next thing is we're gonna have resistor. So this will be R3 and second capacitor C2 in parallel at the emitter. So this is collector base in the center. The emitter has the arrow. So resistor, capacitor, and then capacitor, inductor. We need this kind of transformer, kind of inductor. So let's go grab that. So remember resistor, that'll be R3 and C2. R3 and C2 at the base. So C2 here. No, this is at the emitter, sorry, not the base. So C2, and then we need R3. Yeah, we need this 2 here. And then I'm gonna need C1. And the C1 is closer to the collector. So C1, yeah. And then we need this inductor. So let's go find that inductor. We're gonna go to Easy EDA. We'll go to a common library and look for that inductor. So what kind of inductors do we have here? All right, here we have inductors, but that's not the one we're looking for. All right, this is not the inductor we're looking for. Um, this is axial inductor, so this is not the type. So where can we find that? Okay, we're gonna go to the library and look for the inductor. Um, we're just gonna try transformer inductor to see what kind of inductors they have. So this kind of transformer inductor, but we need um simple one. It's gonna be one coil on one side and one coil on the other side. So let's keep looking. All right, so I don't see the inductor we're looking for yet. Okay, so this is one we're looking for, something similar to this. Let's see if we find something else. Okay, this is also good. So let's grab this one here. Um, so just close this library and then place the component. And then this component has to be around this point. Let's put it here. All right. And everything might be looking confusing right now, but once you wire them up, you will understand. Let's move the resistor and LED a little bit. All right. So this, let's just call it inductor. The inductor, the name is just too long. 8 millihenry. It might not be what we're looking for, but let's just start with this. We can change all the components. I think we have most of the parts we need. Let me go back and see. There's this switch, and then there's a battery or power supply. We might not need these two for now, but for the battery, let's just put a connector. Let's put a connector for the battery. So let's go and look for a connector. We have a connector here. Let's see. Okay. Yeah. So we're gonna take this connector and put it here. Do we need another connector? Let's see. That goes for this. The antenna we can take directly from the board. So let's put one connector, but one pin connector for the antenna. So we go back to the connector and drop it down, select one by one. That's what we need. And then we'll just place it somewhere here. All right, so we have everything we need. We can then wire this thing up. There are some capacitors and inductors that we need. So we need L1. We need this to be our L2 because this inductor is our L1. So we're gonna have this and then that, and then the three capacitors remaining. So that'll be C3, C4, C5. So let's place those C3, C4, C5. So C3 will be here, and it's gonna be in this orientation. C4 will also be here in that orientation as well. And then the last capacitor there is the C5 in the same orientation. So C5, we move it in the same orientation. All right, so I'm gonna use right click to drag it, um, move my LED a little bit, move the corresponding resistor a little bit. And now let's wire these things up. Let's wire them up. So you can press W on your keyboard to get the wiring, or you can click on this here to get the wiring. And so we know that this transistor goes to connect to the capacitor. So if you click before the branching, it will keep your wire there. So it's neat. I like it to look neat. Then come down here, click, then click, and then just um, join that. Then I'm gonna go from the transistor to that connection. Then this one here also to that connection. That didn't get it. So if you see the bubble, let me zoom in a little bit. Yeah, I've connected that. Then I have to connect this inductor to the positive rail. So let me just run that wire right away. So I'm gonna go, let's zoom out a little bit. So run this wire. All right, then I go straight to, I'm gonna get to where this resistor is, because really that's where I'm gonna connect that up. Then I'm gonna connect this to indicate that the power is on. Then I'm gonna connect this LED. So this is just gonna be my ground rail. I'm gonna stop it right where this yeah, I'm gonna connect this up. So let me move the resistor to line up. I like it to look beautiful. So again, W, click, and then click, click, and click. Then I need to get a crystal also to connect across that. So that'll be it. And then I'm gonna connect the base here. Then again, like I said, this one goes to the positive. All right, and this guy goes to ground. I think we're not assuming anything. We just have to check that side goes to ground, and then the other side goes through two inductors in series, and in between that are the two capacitors. So this inductor here comes here, and then this one goes there. And so I'm gonna get my wire one more time, connect this to that, connect this to that, connect this to that. Okay, let's just make it look a little bit beautiful. Connect this to that, and then we're gonna ground this one. I'm gonna ground this one here. Let me just make it come inside a little bit. Then this one here connects to here, and this guy connects to this. Alright, so I'm gonna move this component here. Alright, so because I made this change, I have to just drag this in to make the lines look straight. Alright, and then here my antenna, this will be my antenna, so I'm gonna hit enter to orient it differently. I can put it outside here, doesn't matter. So let me just change the name to antenna. Alright, and the antenna goes to this and not to, it goes to the inductor and not to the and the capacitor goes to the positive, not to the inductor. So we're going to make that change. The antenna here, this wire here, we're going to remove it. The antenna goes there. So I'm going to move this back a little bit. So click and then click, click, and then you can notice the lines is drawing for you, helping you to see where the things connect. For this reason, I'm gonna just move this wire, or maybe I should just delete it and draw a different one. Wire, I'm gonna get connection wire and then down. All right. So that is it. Pretty much, we're done. We just need to connect this guy. This one we're using for the power supply. This connector here, we're gonna use it for our power supply. I'm gonna connect a ground. So let me take this ground, net ground, and just put it somewhere here. And I'm gonna connect it up. But I also need a positive. So the power supply is 9 volts. So let's just take VCC, connect it up there, and then use the wire to. So when I want to drop something and I don't want to drop a second one or a third one, I press on escape. Okay, like when I click on an empty space and the wire starts connecting, like here, if I press escape, it will just delete whatever I've done. Okay, so this is what we are doing right here. So let me rename this inductor. We want this to be L1. It's going to complain because there's already an L1. But then we'll change the next L1 to L2. We're going to get another complaint. Okay, to avoid having multiple complaints, we'll just change L3 first and make it L2. I'll make it L3, sorry. Then there's no complaint. So when I change this back to L2, that won't be complaint. Alright. So I need everything to go from left to right. And then this guy, which is our power supply, we can connect it up by the same way. Get wire from positive from any. Okay, I clicked outside. When you get the connection, let me zoom in. You see like it will form. There's a highlight like a big dot, right? So I'm gonna click on that and then go to the positive rail. I can create nets and just don't have to run this, but the circuit is not too long, so I can afford to connect it up this way. I'm connecting it. We're pretty much done. We're just gonna connect a switch. Let's put a switch somewhere. So let's look for a switch. Um, so this switch, what kind of switch is this? This guy looks like a key, like a relay key, but it's just a switch. So we're gonna take that, um, and then we're gonna just use one of them. All right. So if we're gonna use this, then we have to include it. Let's turn it this way and connect it here. All right. So let's do get wire, and then we go from this point to that point. And then we're gonna connect the open. This switch doesn't look like a real switch, to be frank. It looks like a relay switch. So we're gonna find a different one, but let's just do the wiring for now. It's gonna look like a relay switch, and we can also look at the physical appearance of this switch when we're done. So let's assume we're done here. I'm going to show you how to replace components. So we're just going to go quickly. So this inductor, um, we have to check the component value. Now we're not giving the value of the inductance, so we have to make it locally. So we're not going to worry about that for now. Let's just level the rest of the components. That's 15K and 5K, 6 and 390. So we go here and we double click on the K. That's 15K. Then this one is 5K6. 5K6. Can bring it closer. This one is 390. 390 ohms. Not a K. Alright. And then we have 10p and 82p. 10p and 82p. So let's do that. So this guy here is 10p, 10 picofarads. And then this one is 82 picofarads. Alright. And then after that, we're going to go to the inductors. We don't know the value, so we'll leave it that way. we have to make it ourselves. So we might have to change this from surface mount to through holes so we can make the inductors. And then for the, but we can leave it because we're just showing how to design this. So we're gonna go to the C3 and C4. C3 and C4, 150 and then 100. 150 pico, 150 P, and then 100 P. All right. Then this guy here is 100 N, which is also the same as 0.1. But let's just keep it the way it is. 100. Ah, sorry. This is 22N, not 100N. 22N. And then the resistor here, the value of this resistor is really dependent on the amount of current we want to flow through the LED. So 2 2K2 might be good for 9 volts. So let me just 2K2 9 volts. Um, okay, let's make it a little bit higher. 4K7. So the current that is going to go through this is going to be voltage divided by resistance. So you have to check the current of your LED and you choose the right resistor, because the same current will flow through both the resistor and the LED. So 9 volts divided by 4K, it's almost like say 4.5. It's more a little bit more than 4.5. So you're gonna get about 500 milliamp going through this system. Let me um, just give you the actual value. You might not see my calculator, but I'm going to divide 9 volts by 4,000 divided by 4,700, and it's around 4,000, 1, 2, 3, 1.9 milli, 1.9 milli. If I did, yeah, 1.9 divided by 4.5, okay, it would have been 0.2. Sorry, it wasn't 0.5, but it was so 2 milliamps. But now I'm getting that the actual value is 9 divided by 4.7, so that's 1.9 milliamps, almost 2 milliamps. It might be too small for your LED, so let's reduce the value here. 2K2, let's call it 2K2. 2K2, 2K2, let's see how much current would that um, drive from the through the LED. So 9 divided by 2.2, that's 4 milliamps. 4 milliamps. I think that might be good enough. So check whatever works for you. And but I think this value is going to be too. The LED might be dim if you use this value. So play around with this and find the right value. So we're gonna go ahead and just convert this to PCB. So to do that, we have to save, give it a name. This was called a transmitter 27 megahertz, 27 megahertz transmitter. And I can assure you can build this without all these other components. You can build it without the extra, this inductor here and the rest of the inductors. But the reason you have these inductors is to filter the harmonics, because this 27 megahertz will create a frequency at every double value of the crystal. So if you have 27 megahertz crystal in a circuit, what is going to happen is that at 54 you're going to get another frequency. So the resonance will be at 54, and then you're gonna get another one at 108. Okay, so you can, I think you're gonna get one even before 108. So you're gonna get like at 81 you're gonna get another one. Yeah, so every, it's gonna be just every multiple, every integer multiple. So if you um just look at it as 27 plus 27 54 plus 27 81 plus 27 108 plus 27 135. It's going to continue indefinitely. I think after the fourth harmonic it drops down drastically, but you still continue. So you need this filter to to filter out any higher resonance, any higher harmonic. You just need you're gonna this is a low pass filter, right? This is a low pass filter, so you can pass frequencies below 27, like 27 and under. And since the base or the fundamental frequency is 27, it will pass 27. Maybe you can cut it off at even 30 or 40, because you know the next one is coming at 54. So you can make your inductor, get a value of inductors that will give you a cutoff frequency at 3 decibel at 50, at say 40 megahertz. That way you know that your 27 megahertz is going through, and then anything higher will be truncated. That way you not interfere with systems that use higher frequencies, like your FM radio receiver start from 88 all the way to 108. And so if you're using this, some of them can even go lower in some countries from 79. But what if you use this, you can be rest assured you're gonna get interference at 108 megahertz if you don't use the filters. So you need these filters. And some TV receivers, they also operate at lower than 100 megahertz, so maybe like 50 something megahertz, 57, 54 megahertz. You could have interference on TV receivers unintentionally. But this 27 megahertz is an amateur band frequency, so you can build it and use it for radio controls and other things without fear of infringing on anything. Just ensure you have the filters in place. Now that you have this done, now I'm going to just um, quickly go save it. Okay, I've saved this already. We're going to transform this to PCB. So what we're going to do now is to, okay, I have a different circuit. Okay, let's convert this to PCB. So I'm going to go and click on design. So update, well, I haven't done PCB, so I'm going to click on convert schematic to PCB. Then I'm going to check if there are errors on the nets, and I don't see any. So I can just go ahead and there are warnings, but it's just going to be, let's see what the warning is all about. Okay, incomplete net. Where is that net? Okay, so this pin of the switch is incomplete. So what I'm going to do is I will connect no connection. So there's a I can take a net that is no connection here. This one here says no connection flag. So I'm going to pick that and connect it on that. So it tells the system that I intentionally left it open. I don't need to have any connection there. That's why the running the check is important. So I'm going to run it one more time. See if I have another error. Okay, let's see what is going on with this one here. All right, so what is this? Incomplete net. Okay, he wants me to connect that too. All right, so let me just put no connection on all of them. I'm gonna find a different switch because this one is it has multiple pins that we don't need. We just need on and off switch. So let me run this net first, and then we'll see. All right, there are no more errors. We're still gonna change that later. So it's giving us suggestion how where it starts and the length and the width of the board we want to use. So the unit as well. So we're going to use millimeters, and then copper layers. There are multiple. If you're doing multiple layers, you can select. But let's just do with two layers, and then we're going to start connecting. So this is our switch. This switch is actually good. I like this switch. Um, I like this switch. So maybe we'll just have to keep it. Okay, let's place it on the board. And then this inductor is too big, but we'll just use it for our example. And then the rest of the components are not as big. So this transistor, we're going to place it here. So when I'm going to hit space to realign the components, to rotate the component, the crystal is going to be here. I'm going to try to lay it out the way it is in our circuit. So remember we started from the left to the right. So I want the crystal to be the first thing there, and then the resistors R1 and R2. That way it's just easy to follow. Let's find R1 and R2. R1 here. Remember we're making this surface mount. So let's just do that. R1, we're gonna orient you this way. R2, the same way. And then what again we need? There's this antenna. We're gonna place it somewhere on the board. Um, so this rectangle is where the design is gonna be. If I go to the 3D layout, for instance, let me go 3D right now. You see all the parts, and you can see what we already placed on the board and what are not on the board. So you can see we have this inductor. Don't like the inductor. We're gonna find a different one. But you can see the things we've placed on the board, how they're looking. All right, see how your switch is looking. So I think I like the switch. We might have to leave it that way. So let's bring in other components. So we're gonna drag it in the PCB design. So I'm just gonna drag this guy here. This one is the power connector. Where can I put it? Maybe I just put it here. All right, let me put it here. All right, and then I need the rest of the components to come in. One other way to do this is you can just select everything, highlight everything, and drag them into the board or drag them closer. Let's drag them closer, just allow the LED to be in the board. And then the LED, we want it to be maybe somewhere here. Let's move the antenna. I like the antenna to be at the edge. So maybe the switch, we can relocate the switch. Let's put the switch on this side of the board. Okay, have the switch there. So we can bring this guy down a little bit. This jumper here is the power supply, so be close to the switch as possible. And then the LED, okay, and then the resistor for the LED is R4. So we want both of them to be close to each other. So let's just work on the orientation. All right, now we're gonna put it right above it. And then the other components we need inductors L2 and L2 and L3. They're gonna be here. This L1 is too big, it's ginormous, but we're not gonna worry about that for now. If you select the wrong component, you can just do Control Z to undo. So let's just move this. The L3 needs to come in. Where is the label? Should be close to it. So we're gonna drag L3 side by side, and then we're gonna have this capacitor C2. It's right here. C1 is right here. And then R3 is right across this one here. So since they are parallel, I'm going to make sure that they appear that way. And this guy should be oriented this way instead. Okay. Then C3, it's going to be this way. C4, it's going to be that way as well. All right. And then C5, this is the decoupling, if you will. It's going to go from the positive rail to the ground. This guy here. So I mean, we can put it anywhere we want. Right, let's do, okay, we can leave it this way. I think we have all the components we want inside. We can work on rearranging the labeling so it looks nice. So I don't want to make this video too long, but you can see I've placed all the components in. This one I drag a little bit here, and right. All right, this one I'm aligning this, makes the wires closer to where they should go, other than where I did it before. And since I'm not doing it by hand, I'm just going to leave it this way. Now I have everything aligned. You can see I put the switch closer to the edge, and the toggle or the button is sticking out of the edge because you don't want it to be hidden within the board. I think that's it. The rest is good. It's just aesthetics, how beautiful you want it to be. Normally, I will zoom in and make sure that the components are aligned. Like I can make this to be at the top of the line that way, and then this one also. But this is just based on your own perfection, the way you want it to do to be, right? So then I can also sometimes I make sure these are aligned so that my traces, once I start running trace on a particular line, they will just run on a straight line as much as possible. All right, so let me not waste everyone's time here. Let's go to the moment of truth. I'm gonna go view it on the 3D, so I'll save it first, and then I'll go on 3D. So when I go to 3D, I can see how my components are laid out. Right, I think I like it. Yeah, I like it. All right, we just built one, you know, transmitter right now. Okay, that's good. I like it. This will be used as a remote control because you don't have a modulation, input modulation, but you can add the input modulation to create your input source like a wireless microphone or so. Then I'm just going to change colors like I showed earlier. You can make it green, and we can just label things. We can put labels on it. So let's go and let's go and connect this up. So to connect this up like we did earlier, you press W. Let's move this away. You can take this wire too. If I click on this wire, you just go through the traces, the blue traces. So I can go from here, click on this, and then I just take it to where it goes. I have to avoid things and that. Yeah, so it's connected. Then I'm going to look for another blue trace, this to that, another blue trace, this to that, to then I can just continue. But this is gonna be painful, right? So we don't want to do that. We go to routing and then we on route all, and we can use auto route. So I click on route, and then click on auto route, and then when I come here, I go to design rules, and I want to change the width of the wires. By default, it's at 0.2 54. I want to make it a little bit bigger. If you're going to solder this yourself, you don't want it to be finicky that much. So I just double it. 0.254. It turns out to be 0.508. So I just double it, and that's it. And then I click auto run. It will run, and then wire everything. Total VS created 2 VS. There's none that failed. There are, it attempted 38 and completed 38 routing. So everything is complete here. The routing is complete instead of doing it manually. Now, if I decide that I want to change the width of this wire because I think I need it to have more current, fine. I'll just click on that wire. Then when you go on the right hand side, you will see the dimension of that wire. See, right now it's 0.508. So I can just make it 1, for instance, and then it will just go to 1 right away. I can do the same on any of them. If I just click on that, I won't worry about the ground, and I'll tell you why. Because I want the rest of the board to be ground. So if I want, I can just click on that ground and change this to 1. Right, it just increases to 1, and because it's increased, you can see there's a 1 in here. I don't know if you can see that. This X is telling me that I don't have enough gap between the two, so I have to find a way to take care of that. So one way to deal with that is I click on it and go back. I can put it back to what it was, 0.508, or just do undo and it will go back to what it was. All right, so let's see, did it solve the problem? No, it didn't solve the problem. So let's go back and see. um, Was it always the problem? I think it was always the problem. So let's unroute all again. Unroute all and try to route it again. Auto route. We're gonna keep the same dimensions. Let's see if we had the error at the first run. Okay. All right, the error was not there at the first run, so it was just introduced when we increase the width. All right, so we're gonna leave it this way. I want to put a level on it, and we're gonna put text on it. So the blue wires are on the back side of the board, and the red wires, the red traces or routes are on the top side of the board. So I want to put some text. So you press the letter S on your keyboard, and it gives you text. So you can just call it. You click anywhere to place it. Click anywhere to place, but I just need to. So this one I'm gonna call it, or maybe I don't need to. Let me use one because I want to reuse the text. So here I'm gonna call it 27 megahertz 27 megahertz crystal transmitter. All right, so I drag it and place it wherever I want. Now it's going to cause a lot of problems. The text is also too big, so I'm going to reduce the height, go on the right hand side and change it to 1. Then I'm going to drag it and look for where there's enough space to have all those texts without crossing my wires, and I don't see enough space for that. I don't see enough space for that. So what I'm going to do is also another moment for us to learn something new is I'm going to try to drag this purple line on the right hand side. If I drag it out a little bit, it will just increase the dimension of the board. Then I'm going to click on the text and press the space bar to reorient my text, and then I can place it at the corner like this. All right. Then since I said I was going to reuse that, I just press S again. It will have the entire text for me, but now I want to put it at the back of the board. So I'm going to select the back, the bottom layer. When I click on it, it will invert the text will be inverted or reversed. So I'm going to place it somewhere, then double click. It will be uh, uninverted again, so I can edit and type if I want. But I want to keep it that way, so I'm just going to drag it and then put it anywhere I want where there's no blue line. If I put it on the blue line, I'm going to get a complaint. So I'm going to put it anywhere else. Even if there's red line, it doesn't matter. Why? Because the red lines are on the top of the board. So you will see that text when you turn around the board. And I think that's all I need. I just want to, this is labeled as switch 1 already, so I will leave it that way. This jumper is power supply. So let me do S. And I'm going to change it to the top. So I'm going to click on top of the board. And I want to call it power. So I'm gonna PWR, and then I'm just gonna rearrange this, and okay, let me put it this way, put it close here. So that's my power. So, and that should be my positive as well, and the other pin is the ground. So I'm gonna get another one. I won't call it power now. I'll call it positive plus VE. Then I'm gonna call this GND. So I'm gonna grab the ground and put it closer to the ground, which is here. I'm gonna grab the positive and put it closer to the positive, which is there. All right, so power comes in to the positive, goes in through the switch, and when the switch closes, it just sends the power to the rest of the circuit. Right. All right, I think, yeah. And then this guy, the capacitor decouples or filters and grounds. So we're done. So the next thing I want to show you now is how to put the ground all over the place. So you're going to press the letter E on your keyboard, click OK, and then you just click at any corner beyond the board, and then go to the other end beyond the board again, click, drag down, and then click, and then go to the other side also and click. Not really drag down, just move your mouse around. Once you're done getting all the four corners, you press escape, and automatically the ground is applied. Now I want to do the same thing on the back of the board. So you select the bottom layer, then I'll do the same. Press letter E, click on OK, then I'll start clicking again. Click, move your mouse to the other end. You can start anywhere you want. To the bottom, click, go to the other end, click, and then go to the top and click, and then press escape, and then it applies. Right, so if I go to the top, I can see the top layer of my board. And then if I click on this side, I'll see the bottom layer of my board. That's it. All right. So you can see my ground now, even though it's connected everywhere. Let me see if I go to look at just the ground. I want to sorry, I want to look at the bottom board. Yeah. All right, this side of the board is everything that is blue um, is actually grounded. So all my ground is going to the bottom of the board. Everywhere is ground. And now this is my antenna. I can change the name to antenna so that it's easy to tell. Um, so it's a 30 centimeters antenna. So I'm gonna say 30 centimeters. So I'm gonna just give it a label. So another S. So I can, but I need it on the top of the board, not at the bottom. So S. All right. So let me go. I want to show my top of the board, and then okay, this is not ground. This is antenna, and I can, if I want, I can put 30 centimeters on it, but I don't think I can see enough space to put it on top of my board. So you might have to go at the back of the board. But let's see. And so let me remove the masking on the top of the board so you can see where to put it. I'm going to reorient it and then put it here. All right. If I think it's too big, I just click on it and reduce the size. Let's reduce the size to 0.8. All right. Okay, I think that is fair enough. So if you want to put more text, you can go ahead and do that, but we don't have to. So now we're just gonna put the ground in again. So I'm gonna do E, click on OK, click anywhere outside the board, and then on the all four corners of the board, then escape, and then this should be applied. All right. Okay. So let's go ahead and look at it in 3D. Move all these around. And we have to create a new 3D. Before that, we have to save what we've done, and then we have to just go and click on 3D. All right, this is beautiful. I like it. So you can change the color. I like red, so let's do red. So right there, you have just built your FM, sorry, not FM, but crystal transmitter, 27 megahertz crystal transmitter. You can put the level of the crystal. You can put anything you want, just like we did the text. You can put the text whatever you want. You can do this from the component level so that it's showing in white color. Or you can also do it on the board level when we're using the S key on our keyboard to create that. So here I'm going to put my power supply. So that's my positive, that's the ground. I put my power supply here and then the antenna over there. And this should work. You have to find the right value of the inductor. Here they're saying 12 turns and 3 turns. Obviously, like a transformer, it will be a step down transformer. Um, and then so you can just uh, do the coil yourself and create the circuit that we've just done. If you want to replace any component, like I said, you can go ahead and go back to the schematic and replace the part. Like this one, I don't really like it. I can try to look if I can find something different. So to do that, I just go back to the library. I used to see a component that is better than this. But now I'm wondering if it was in multisim or if it was this easy EDA. There are other tools that I use for simulation, and I think I used to see better inductors. So I'm just wondering if that was where I used to see this. Um, let's see inductors. Let's see if I do 12T to 3T inductor. I haven't searched like this before, but I'm just gonna try. No, it doesn't. Let me try step down. Let's see if I can get. All right, it's just gonna be like a transformer, as you know. An inductor is a transformer, and also a transformer is an inductor. So is this this is what we used already? This type of inductors. We'll just go through and see. But basically, we are done here. The next thing is to order your parts from JLC PCB, you can go ahead and order that. And this part you're going to make it yourself anyway, so you don't really need that. You just need to have a placeholder for the inductor. But really, I have a strong feeling that the inductor should be here. Let me just do this. Escape. And this switch I don't like, to be frank. Um, this switch I don't like. Yeah, let me try to see if I can find switch. I know I accepted it because I like the way it looks, but in terms of the connection, so if you want to use this kind of switch, so it's kind of a limit switch. So when you hit something, it will stop. But that's not the kind of switch you're looking for. Yeah, the kind we just used is similar to this. Um, but let's see if we can find. Anyways, I'm showing you how to replace a part. I'm just gonna replace one part just for the sake of it, so that you see how it is done. So now instead of checking forever, why don't we take the one that we saw that is similar to what we did? This guy here. Let's take this one here. Let's take this one here. So we're gonna go close this out and just play the switch on the board. Okay, then exit. So I've placed the switch. I'm gonna grab the switch, and this is single pole double throw. So it's a double throw switch. I don't think we need double throw, but we're just gonna use it as an example. So we reorient it again like we want, and then we just connect it up. So I'm gonna connect this here, drag it, and then connect it here, drag it. Yeah, I can actually connect those two together, or maybe I don't do that. Let's just do it this way. Get the wire, connect from here, and then terminate it at the switch. All right. I don't think I need that terminal. I need the other one. I need the center. Okay. Then I'm gonna take one of these no connections and put it on the other terminal. Then delete the access. And then I'm gonna save. Then I will update my PCB. Design, update PCB. All right. It tells me about the things that are being removed and things that are being added, and the nets that are affected. But now in this case, the the switch is not on the board anymore, so I have to bring it in. Okay, I think I want it to be like this. All right, there's going to be a lot of errors here, so I'm going to delete the grounding, and I'm also going to unroute. I can manually do this, but because the circuit is so small, I don't have to do this myself manually. So let me just remove all the masking and all the routing, and then I'm going to do the routing again, auto route. Then I will make sure that I have the same design rules. I want it to be twice, yeah, and I'm going to leave the clearance and the rest of them as is. Click on OK. It will automatically run and route all the wires for me. So there's one VI this time around, which is fine. And then yeah, I'm done again. So I'm just gonna so okay, let's see. Yeah, so if I go on this side, it will close the switch. If I go on the right side, it will open the switch. So I can just put a label here S, and I can call this on and off. Right, so call this off and call this on. So for my on will be when the switch is on this side, it will be on, and when the switch is on that side, it will be off. All right, and then because I've done this now, I have to save again. So go here, click on S, and then I hit my E again to get the ground. Then click here, there, there, and there. The first time I used this, I didn't know about this escape, and I was wondering why it doesn't put the ground when I'm done. It just keeps hanging around. Let me show you. When we do the bottom of the board, E, press OK. If I click on here and I go there, click, go down here, click, go right here, click. It doesn't know that I've done 4 corners or 5 corners or 150 corners. It just keeps waiting for me to. I think if you double click, it will still be dragging. So escape, and then it will apply. So I'm just gonna click on the top to see the top layer, click on the bottom to see the bottom layer. And you can see the on and off are now part of the board. If I wanted it to be different, I could have on the on this side of the board, I could have given it the name, whatever name I want. So instead of slide switch, we already know it's slide switch, but just to give you an example. So a slide switch here, right? Then when I save and I update the BOM, design, then update the PCB, all right? It tells me what I've changed, and then um, switch S2. Okay, you can put it there. So the other characters didn't come through. So let's change it from S2. What can we call it? Maybe on the same line as S2, we can give it another name. Power switch. Let's do power PWRSW. Okay, SW. Let's just call it PW. Yeah, let's do that. It doesn't take that. I can't edit this. No, it doesn't take that. Anyway, so it doesn't take that. So the only way to change the label then, cancel please. The only way to change the label then is to come from here and put the text that we've done. And I think we're done here. Now I want to put some holes because I want to be able to drill holes. I want to be able to screw it down on a board. So what I would do is you go to this PCB tools and you pick the hole tool here. I click on it and then I click anywhere I want the hole to be, where I want to put the screws, and then I put another one here. So that's it. If I don't like the width, I click on it and I'll change the dimension of the hole. So right now is at 2 millimeters. So I'm going to do 2.5. This is just to show you that you can change it. There's nothing really why we're doing that. So change it 2.5. And if you notice something, there are some errors. This is complaining because there are some wires that I'm touching. You see those X, but here I don't see it. So I can place it. No, I still see it there. You know, because of that, I'm just gonna place it anywhere I want. I don't care about what it's complaining about. Place it there, and then I go ahead and delete the earth or the grounding. If I delete the grounding, I can actually see if I'm causing any problem, and there's no problem with my wires, my wiring, right? I don't see any problem with or interference with my wiring, so I'm okay with that. Then the issue was that I was cutting off the ground, and because this is not a human being, it doesn't really know that it's nothing. It's just the ground, right? And the entire place is the ground. So I'm gonna do that again. I'm gonna do the quick now. Click, click, click escape. Then we'll do to the bottom. E, ground. The net is ground. Click, 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 click escape. I think you actually need this for RF circuits because you don't want some stray capacitances or inductances. And when you're placing components in an RF circuit, you want the components to be as close to each other as possible. Because in this circuit, you have something like an amplifier, which is this transistor, and then you have the frequency determining network, which is this crystal, and then you have the feedback network, right, through the um, emitter circuit. You have the feedback system, and then you have here the filter. So the output originally is from this tank circuit, but then you have a filtering to a low pass filter to only allow 27 megahertz or something close to that, but definitely less than 54 to pass through, right? And then this is it. This resistor and LED we added ourselves from the original because we want to indicate when power is on the system. So that's it. All right, go ahead and build yours. So let's go ahead and order this part from um, JLC PCB. So I'm going to save this. I'm not going to order it. I just want to show you how to do it. So you just go to Gerber file, click on it. You check that everything is okay, and it seems everything is okay. All right, so one click order, or you can generate your Gerber file. It will generate and save. It's generated and saved on my computer. I'm not going to open it, but you see how it's done. So I'm going to go again and do it again. Uh, okay, check. And okay, let me show you this one here. Go on, I've checked again. It goes to JLC PCB. And then here I can place my order. Okay, so I can just wait for it because I am doing it from the design. It should upload the Gerber file automatically. Yeah, so it's uploading, and then my board is here, and then it gives you an estimate how much it will cost you to print it and all that. And then if I'm doing this kind of thing, I want them to solder it for me. So I'm going to do PCBA. So that's the PCB assembly, this one here. So I'm going to do PCB assembly. So they're going to place all the parts that they have, and the ones they don't have, then they won't place it. You can also include there are files that they'll ask you to include. When you include those files, you can remove in your BOM. In your BOM, you can remove the inductors because you're going to make those inductors, right? And I will propose that when you do this, you actually go and find out the inductors that will give you the the low pass filter that you're looking for. You don't want to base it on this says 15 turns, I think. Let's go back. Here it says 15 turns and 8 turns. You don't want to base it on this because you don't know what value this, how many turns are here in this surface mount. So just go ahead and do your calculation, find out how much inductors and capacitors, how much frequency they will allow, or the cutoff frequency for that network. It's a filter network. Find out the values and get the actual values, place it here, so that what you're making on your own is very limited, right? Even this inductor here, maybe you can make this because there's no clarity here how the inductance came about, right? So I don't know how it came about, but you need to be able to couple both systems. So that's one thing I don't understand. One thing you can do, you can change the design entirely yourself. You can replace this component here with a resistor. You can replace it with a resistor and then just have a capacitor from the output to go to the filter. You can do that. There are other crystals on the internet. Let me show you one of them. Let's just check 27 megahertz crystal transmitter. And then you get the images. All right, so let's look at this. So this guy used those um kind of transformer, but this one here, this one used it too. I'm looking for one that didn't use it. Let's look at the ones that didn't use it. This one didn't use it. Maybe this one here. All right, so the crystal. So this guy didn't use that kind of transformer. So you can, from the output circuit, you just go to your filter, right? You can go to your filter from there. This one used the transformer as well. Now we are looking for one that didn't use the kind of transformer design. This guy didn't use the transformer design. So from the out, you can design this and take from the out to your filter, to your low pass filter. Now, one thing I want to establish here is that when you're designing a circuit diagram, and I think I've done this in my previous videos, I've explained to you that the basic thing you need is the block diagram. You need to know how to generate a block diagram. Once you have a block diagram of whatever you want to design, you are good. You are good to go. I'm telling you the truth. You are good to go. If you know the block diagram, you can build anything. You don't have to be stuck on the actual circuit that the people used. You can just use block diagram to recreate the same system, right? The important thing is that you know how these things work. So you like, let me recap and then we close. So we've designed a circuit. We went to easy EDA and we created a circuit. We created a circuit for ourselves, and the circuit is a crystal transmitter, crystal based 27 megahertz transmitter. So that is our schematic. We put the parts, and we've seen how to change replace a part if we want. So we put the parts together. We converted that to PCB, and we had a preview of what the final system would look like. And if we liked it, we can go ahead and order it. And this is where we are now, so you can just go ahead and order it. I'm going to stop here so far, but you've seen it to this point, and these guys are always responsive. They are online all the time to respond, so you can click on this and have a chat with JLCPCB. This video is not sponsored, but when I see something good, I like to share it. So go ahead and make your own circuit and make your life easy. You can order up to 5 boards. I think minimum of 5 boards or so. So go ahead and order. You just click through the next. If there are errors, it will tell you. Like now there's an error, parameter exception. So I'm going to chat with them. If I want to order this, I'll chat with them and say what's going on. I'm not able to do this, and then they will respond and tell you what to do. Right? There are things I have to click on yes, no, why I'm doing this project. They want to make sure that what you do using it for is legal and the rest of them. So you have to go through and answer all these questions. And once you're done, you can go ahead and place the order. The order normally arrives quickly. Let me see if I can find. Yeah. So it can be printed in 24 hours, 2 days, and so on. So there are different quotes. 24 hours, you don't pay extra for the PCB time, and for 2 days, you don't pay nothing. 24 hours you pay something. um yeah, I don't know, there's a lot of things you have to go through when you want to order it, and then you have to pick your shipping method as well. So bottom side there's nothing there, top side there's something there. I want the standard board, and I have to get um okay, let me just say I'm confirming. Do not confirm automatically. Stencil storage, I don't think I need stencil storage. Part selection, I'll let them do the part selection, and let me see if it's enough minimum. Yeah, okay, yeah, so that's minimum that I need to do. And then I have to upload my BOM, which is the bill of material. And the bill of material, you can get it from your circuit because you're the one that designed it, so you know the components. So you just have to list the components. That's the BOM, the bill of material. You upload the BOM, and then this one here is a file. It looks like a BOM as well. If you look at the example, I'm not going to show that. Let me just, if you look at the example, the I don't know if this can show online, but the example looks um like BOM, to be frank. It tells you some, I don't know if you can see my screen right now, but it tells you something about the component that is on the board. So it's kind of, for me, redundant. That's one of the things I don't understand why they ask for that, because the circuit is already coming through. They will say like this part two, you need two of them. This one you need three of them. That one you need one of them, and so on and so forth. It seems to me to be redundant. If you have the BOM, you have the Gerber file as well. But that's what you do, and then you order your part, and then within a few days you are building the system at home. And if you ask them to do the PCBA and they had all the parts, then it will be faster because it comes already um, complete. I can show you some of the things I've done with them. It's just gonna mean that I'm gonna get up from here and go grab something I've done with them. So give me a second. I know that we are on for how many minutes now? More than an hour. So I don't know if it makes sense, but let me just go grab one quickly, and I'll be back. All right, so I have the part here with me. Um, so from JLC PCB, and I've made a lot of stuff with them. So this one has some parts soldered on them already. So because they are tiny surface mount components, I didn't want to solder them myself. So I asked them to solder that. But there are also other places where I need to solder things myself. Those ones are open. I have to solder them myself. All right, and then there's another one here. This one has a lot of micro components that you know I have them solder, but there are also other things that I have to solder myself. And this arrived in record time. Um, this other one here, I have not so they haven't soldered anything for me on it. So just the plain board. I have to solder everything myself. All right, and then last but not the least, all right, I think I've shown you this one here. And this one is also similar. So yeah, I've shown you a type of it as well. So that's it. Like I've said, I like red, and that's why most of my boards are red. Apart from this green one, I do red and green. So you can choose any color that you want, and they will be happy to build them and ship them off to you. All right, I think we've spent time today, and we've done quite a lot. So thank you for sticking around to the end. Please do like, share, comment, subscribe, and I will see you in the next one.